Hi everyone, I'm Christiane Zhao. Welcome to our video. Today we're going to talk about what is telehealth. The reason why I created this video is because nowadays telehealth service is widely adopted in many of the country and it's become a very mature service in many of the healthcare and non-healthcare setting. However, there are still lots of people, especially university students, they are not sure about the concept of telehealth. That's why I would like to share this video and talk about telehealth and its implications. So before we start, I'm going to introduce myself. My name is Christiane Zhao. I'm the founder and the former president of the Healthcare Technology Association New Zealand. And I'm also expected to graduate with a Bachelor of Science and Bachelor of Health Science degree at the University of Auckland in May 2020. If you're interested in me or interested in the association, please go online and search for us. Thank you very much. And if you'd like to interesting look at other videos, please go online and search for viamod.com/caretechdia. Thank you very much. So before we start, we're going to talk about several things. So we'll first define the concept of telehealth and telemedicine. Because a lot of people thought it's the same thing, but it's actually slightly different from each other's. And we will talk about the history of telehealth. We will talk about the technology we use in telehealth, and we will go on and look at one of the subsections of telehealth service, which is telediagnosis, and also the implication of machine learning in telediagnosis. But we will see how long can we go. Do we go? And because especially I try on making this video for several times, and it goes too far away, and I spend like much longer time to explain the first three sections. And we might create a new video to talk about telediagnosis later, if it is too long. So let's look at the definitions. I do look at a few definitions online about telehealth, and I found this definitions is given by the American Telemedicine Associations. It defines telemedicine as the use of medical information exchange from one side to another via electronic communications to improve a patient's clinical health status. As mentioned, it's the definition for telemedicine. Telehealth is actually slightly different. A lot of people use those two words in a report and they refer to the same thing, but telehealth is actually an umbrella term that covers telemedicine. If we highlight several words in these definitions, telemedicine must be the use of information exchange, medical information exchange actually, from one side to another, which is via distance. Through electronic communication to improve a patient's clinical health status. So a telemedicine service must be used in a clinical health setting. Telemedicine, yes. But telehealth is a broader concept. Any form of the telecommunications that is aiming at improve a patient's health conditions or health status is referred to a telehealth service. For example, if I send an email to my GP and ask my GP, oh, what do you think about my diet plan? Do you think I need to change it? And then my GP reply me with a detailed email to talk about how can I improve my diet choice. And in this case, it is a telehealth example, but it's definitely not a telemedicine example, because it's not in a clinical setting, it's not an exchange of medical information. But as we go on, we might use the telemedicine terms a lot because for a lot of the information I search online in the United States, they are mainly focused on telemedicine based on lots of different reasons, but it's nice to adjust that. So the term in here, telecommunication technology, is actually the from the communication infrastructure which enable various connected care options. And also, as the advancement of technology, the reason why I said telehealth is widely adopted is because almost every type of the health professional use telehealth service. For example, they talk to patient via telephone, right? They send email to their patient, as I mentioned, and they even send a person's electronic health record to a diagnosis lab, right? And we even have video conferencing from one country to another country, from one hospital to another hospital. Sorry for that. On a daily basis. So telehealth service can actually be classified into 4 categories based on its functionality and its purpose. So we got live video conferencing. We have store and forward video conferencing. We have remote patient monitoring and mobile health. So what is live video conferencing? You can see from the words, it's actually a two-way audio-visual link between the patient and care providers. It's a live video for the purpose of communications or meeting that's related to healthcare. And then we have store and forward video conferencing, which is a transmission of a record health history to a health practitioner, especially specialized. For example, like a nurse can record a patient's video and then send it to a cardiologist, right? This is just an example, might not be really implemented. But anyway, but please carefully look at those definitions. The reason why is because for places like US, we are heavily relied on the insurance. The way that the insurance company define whether they're going to define the telehealth service is strongly related to those definitions. For example, like for many of the states, they're funding the live video conferencing, but they're not funding a store and forward video conferencing. But on the other hand, that the store and forward video conferencing might require less data to transmit video or informations. The live video conferencing are having a higher minimum requirements on the data transmission and the speed of your bandwidth. And for the remote patient monitoring, there's actually several people ask me for this because you might not be able to clearly see the definitions from its name compared with the previous two we talked about. Remote patient monitoring is actually the use of a connected electronic tool to record the patient's personal health and medical data in one location, but for review by another providers and another locations, and it's usually for a different time. And then we have mobile health. Mobile health is the most popular category in telehealth, in my personal opinions, because as with the advancement of technology, mobile phones getting cheaper and cheaper, and electronic devices are cheaper, and we are able to track our personal health record and communicate within a distance in a very low cost. So the definition of mobile health is healthcare and public health information provided through mobile device. It's a very broad category. So we're including general education information, targeted text, and notifications about disease outbreak. As explained, one of the main reasons why mobile health becomes so popular is because nowadays lots of people are owning more than 1, 2, or 3 actually mobile phone. From one of the reports we saw online several times in several conference is the number of toothbrush that people use is even less than the number of mobile phone that people are using. And of course, mobile health service is not limited to mobile phone only. It can be laptop, it can be smartwatch. But mobile health, and a good example of mobile health is several projects that the Ministry of Health and the Waitemata DHB in New Zealand have developed throughout the years. The Waitemata DHB is very well experienced in telehealth service. They have provided several text message program actually to pregnant women to talk about to give them more medical information, healthcare information about a pregnancy. They're also having program to text smoker about quitting smoking. Program to diabetic patients to talk about their conditions and also their mental health. Text message is usually cheap, and we're able to reach out to a wide range of populations, because nowadays lots of people are having a mobile phone, but of course it might not be a smartphone. But no matter what, text message can be received in any of the phone nowadays, even though you don't have access to internet, which is quite important. And again, smartwatch is one of the good examples. Like for example, like Apple Watch, they are able to chart your ECG, your heart rate, and then use machine learning algorithm and method to sort out whether you are a high risk or low risk patients in heart disease. And let's keep going. And when we talk about telehealth, we definitely need to talk about its history and positions. I spent quite a while to find this picture online, and it's quite interesting. And this whole history is actually to show that telemedicine or telehealth is not a new concept. It had been existing for quite a long time, but it's just slowly adopted in our current system and society. And then I will talk more about it. So in April 1924, this word telemedicine is first appeared in a radio news magazine, which is quite quite famous magazine. And you can see the cover of this issues is a drawing about physicians viewing a patient through a television light screen via shortwave radio set. This boy sitting on the bed on the left-hand side is facing the televisions and then showing the doctors about his conditions. Like he opens his mouth, show his hand, right? This is at that time, this is still a very ideal and pioneer concept, but as time goes by, it become a symbolic picture, because at the time people didn't imagine it could actually happen, and now we have it everywhere. We have camera, we have video, we have live conferencing, right? And in 1995, which is approximately like 60-70 years ago, after. We have a first telediagnosis applications that is developed for dermatology, like for skin, like for example, like skin cancer. And it's very popular nowadays that a person can use their phone to take a photo of their skin, and then share it, upload it to a cloud, or share it to health professionals, dermatologists, distance away. Like for example, like in New Zealand, we don't have many dermatologists. And then those specialized are usually living and located in the center of the city. And so what we did is we create a Facebook group, and we got lots of dermatologists in there. And sometimes the GP will upload photos of a patient's skin, of course with the permission of the patients, and to Facebook. And then ask, what do you guys think about it? I thought this is this kind of a disease. It's actually quite interesting. But anyway, and then let's move on. After 2 years, we got the study was published about an experiment of two-way video communications for emergency device between the Logan International Airport and the Massachusetts General Hospital in Boston. It is a very iconic experiment. A very successful experiment that we have done in history. And then we will talk more about it when we move to the telediagnosis sections. Bear in mind that at the time we don't have very advanced technology. It's not too far away from the Logan International Airport and Massachusetts General Hospital. But they do need to implement a cable and actually a wire to transmit information, and then they got a very small screen on each side, and then you can see the person is like in that small screen, and then you guys are talking to each other's. But of course, there are lots of limitations at the time, because they are not able to receive a high quality medical image. Not those from the internet, of course, not like nowadays. But after all, it's actually a very large experiment. They diagnose approximately 1,000 patients in the general hospital. But of course, those patients are in Logan Airport. Be bear in mind of that. And actually, those even though those programs are very far away, happened a long time ago, and we don't have a very advanced technology at that time. Things change, the system changed, but those program actually represent a new modalities in the healthcare system, but also it have like those program like those telehealth program have drawn conflict due to their regulatory issues and sustainability. Why is telemedicine so important? Is because it perform a new way to enable patients to connect with the doctors, with the healthcare system, and also it provide a new way to communicate for general healthcare professionals with the specialized that is far away to enable them to have continuous education throughout their career. Those two relationships are quite important and the main driver of telehealth. And of course, not to mention the inequality in the populations and how people with less resource are not able to access to healthcare facility. But with telehealth, we have the possibility to achieve that, right? We'll talk about that later. But even though you see a lot of very successful example in the experiment side in those published study, but once we move beyond the clinical need, the financial and legal implication of telehealth or telemedicine is actually challenging the status quo of the industry, because once you are able to access to your healthcare professionals via technology, you might not actually need to visit the clinic. You might not need to visit the hospitals. In some cases, the doctors do not need to rely on the whole legal system to be able to function. It might not be right in the United States, but it could be right in many places in the world, in Australia, in New Zealand, in China. Especially in China, because I heard a lot of rumor about its implication of telehealth service. But again, any sort of the new technology can be challenging for the existing party that is playing in the market. And as we said, telehealth service is great. The technology is simple. It's getting widely adopted, but it's very slow. We do see a lot of program that's running in the United States. If you go online, if you go to American Telemedicine Association's website, you can see the program that they have done, the program they are running now. They might running 5 to 6 programs at the same time. But whether it is possible to be implied in the larger scale, in the population-based scale, there's a question for that. And it must be heavily relied on insurance company. And for New Zealand government is very positive to telehealth service, but there's also other problem come up which could slow down the progress, and we will talk about it when we move to the technology side. So after we talk about the history, we will talk about the technology that is used in telehealth. Different with many health tech product we have nowadays, telehealth service is based on very, very simple technology that we have been widely used for a very long time, for decades. Like connectivity is vital for technology and telehealth service, because broadband networks are the foundations of telehealth solution, like mobile technology, live and store and forward video conferencing. Those that require an essential or a minimum quality of bandwidth to transfer information in a timely fashion. So it is necessary to have a national or broadband infrastructure, no matter where you are, especially in both rural and urban area. But well, the reason why we need that is because cellular data is quite expensive. Even though cellular data is an option, but in New Zealand or even in the United States, it's quite expensive. For example, like if you want to have a mobile phone plan that have unlimited amount of data, it costs like approximately $50 to $60 per month. Imagine how many people can afford that in the United States. Even though we do have quite a large amount of people able to afford this, but the population who need healthcare the most, who do not have access to healthcare, might not be the population that have access to expensive cellular plan or phone plan. In this case, we will create technical divide. The only way not to create a technical divide is to have a sustainable national broadband network. The term technical divide means people who are well off, people who have more resource in the society, are more able to access the new technology related to healthcare. And then people with less resource, people with less accessibility to technology and healthcare will end up not able to receive the benefit, and the inequality between those two groups will be widened once we implement the new technology in the market. So as mentioned, New Zealand and United States have the same problem. Those countries have great disparity among rural and urban area. Like for place like for United States, in the middle of the United States, we have those medical desert. You might need to drive like 2-3 hours from your hometown to a general hospital to receive the service you need to have in emergency situations. Imagine that. And also in New Zealand, it can be very common that you if you are living in far away from the main city, it actually takes quite a long time for you to get to the hospital. But anyway, yeah. As mentioned, if you need to have a lower speed connections, if we don't have the technology, a store and forward service is actually a possible options. But as I said, lots of the insurance company do not recognize that as a telemedicine service. So it's very tricky, and you do need to carefully look at your insurance plan if you're interested in adopting or using a telehealth service. It is also necessary for the telehealth program staff to communicate with the local IT staff to then demonstrate the existing infrastructure before they actually purchase a new telehealth platform. If you purchase a platform randomly, just based on what you like, it might not be able to implement or integrate into this existing IT system or service, then it can't be used at all. And also apart from connectivity, there are also other equipments that can help you to improve the quality of the telehealth service, like camera, real-time videos, or even an online platform that's enable you to transfer medical image and electronic health record data while you guys are talking to each other. Like, for example, if a patient or if a person having a smartwatch, and the smartwatch is able to record a person's heart rate, record a person's walking distance and life behavior, and this person can actually transfer those personal health lifestyle data to their doctors while they're talking, while in the internet, and it can be one of the options. But again, even though like telehealth technology is very popularized because everyone is using a phone nowadays, but it is also one of the fastest changing fields. So always adopting existing and new platform of can help you to exchange information and to optimize interactions. But of course, the main point is the clinical requirements must be matched by the technology requirement, as well as the well-designed infrastructure to enable a sustainable telehealth system. So different from lots of the health technology you saw today, there is one of the reasons why I introduced telehealth is because telehealth service is heavily relied on the existing system. It's heavily relied on the infrastructure we are having, heavily relying on the current existing traditional healthcare system, and even the pharmacists around us. So compare with other technology, telehealth service might less likely to challenge the status quo because it can optimize interactions and maximize benefit. But of course, telehealth can be more widely adopted in the public healthcare system because if the government is the main payer, they do want to save up and they do want to do things in a more cost-effective way while they're able to improve the quality of the care. But for those private hospital groups or for those like healthcare system, they're heavily relied on your out-of-pocket fees or the insurance company. It might be more difficult to implement an entire or nationwide healthcare system. So let me go on. Yeah. If we keep going on, I would like to draw on one example, which is the subcategory of telehealth. It's called telediagnosis. The definitions of telediagnosis is given as the detection of disease by evaluations of data transmitted via telecommunications. In such of the cases, for example, it can be a real-time diagnosis management for medical equipment. In the past, telediagnosis was the term that was used for medical equipment management, for factory machinery management. Because you imagine when you have a huge factory, probably 50, 60 years ago, when the machine breaks down, you might not know that the machine has broken down because those machines are not connected to internet. You don't know what is going on, and the management team don't know, and the workers who are using the machine don't know what to do. So a telediagnosis system definition has been introduced in those kind of the cases to deal with those breakdown machine or breakdown, supply chain. But nowadays this term has been more widely adopted in the clinical side. So ideally, a telediagnosis system is to utilize diagnosis instrument to provide a clinical experience that is similar or as well as the patients and doctors sitting within the same room. So that is the ideal case, that to provide a high quality of care or service experience, no matter they are within distance or not. When this concept being applied in healthcare, it become very popularized, especially when the mobile device come in and people see it is possible to remote transmit information in a very lower cost, and a large scale of the population are able to use those device. And let's keep going. So as mentioned before, we do have several experience or study that we have done in the past to talk about telehealth. And I had also mentioned there's a revolutionary experiment have done in 1974 that between the Massachusetts General Hospital and Logan's Airport. The reason of why this experiment is very revolutionary is mainly because there's no other large scale experiment they've done in this case. So in 1974, one of the first diagnosis device experiments that have been done in East Boston. They have implemented a 2.7 mile two-way audio-visual microwave circuits between the airport and the hospital. As we said, we don't have Wi-Fi at that time. And then this experiment is able to provide a primary care service for approximately 1,000 patients during the study. And in the past decades, after the experiment have done successfully, there's actually an increased number of telediagnosis research related to cardiovascular disease, Parkinson's disease, or long-time chronic disease management, or skin cancer, as we mentioned. As we can see that telediagnosis, as an example of telehealth, is able to provide new opportunity to imagining how the care is delivered in a more efficient and efficient way, and more accessible way. And it also holds the promise for improving the quality of care for the rural populations, as well as the populations who are not able to take the transportations and go to the hospital or clinics. While we see the huge inequality in the rural populations, we are also having a very highly unequally distributed distributions of care professional and facility. You do see most of the professional might be in the city centers. For example, like in New Zealand, most of the professional might be in the large big city, like Auckland, Wellington, Dunedin, Christchurch. But you might not see many healthcare professionals in the rural area. And same in the United States. That's why an increased use of telediagnosis is actually enabling the local hospital staff to receive support from specialized easier, and also enabling the patient to respond to a professional guidance in a timely manner. Those two are actually quite important. But again, we are not so sure whether the implementation of telehealth service will widen the inequality or reduce inequality. It really depends on how you implement it. When we talk about telediagnosis, I also want to raise the topic about machine learning, the implication of machine learning and telediagnosis. I will first define the term artificial intelligence and machine learning first, and then we'll provide a few outstanding examples of machine learning-based telediagnosis. So the term The term artificial intelligence is defined by many people actually. And I found this definitions by John McCarthy. This definition has also been used in FDA. He defined that AI is the science and engineering of making intelligent machine, especially intelligent computer program. I think in short, it can be explained as the task of using computer to understand human intelligence. But of course, AI does not have to confine itself to methods that are biologically observable. And the result of AI is actually mainly depends on the data you input and the algorithm you developed. The term AI became very popular in 2007, but it is a very old concept, just like telehealth. It became popularized in the academic or in the scientific field in 1980s and 1990s. At the time, there is an increased amount of research and clinical trials have been done in the field of artificial intelligence to improve disease diagnosis. While there are actually only a few health-related AI systems have been actually incorporated in the clinical practice nowadays, but we still have a large amount of the AI-related health study to show a great potentials to enhance the use of telehealth service for the populations that mostly need with the use of AI and machinery. The reason why I'm focusing more on machine learning in this case is because I realized the term AI is too broad. It covers so many different concepts and so many different ways to deal with the data. So we're focusing more on machine learning, especially machine learning and computer visions as two of the main method we use in diagnosis and telediagnosis. Let's keep going. So when we talk about machine learning and telediagnosis, I do want to mention that in June 1998, the FDA actually approved its first chimerical unit for the computerization's detection of breast length and mammograms. This is actually what does it say, a main turning point actually, because a lot of people don't really know FDA did approve AI diagnosis system as early as 1998. And then I tried to search for the definition for machine learning. And again, there are lots of definitions, but there's one widely used, which is by Mitchell, and his definition is pretty long. I can read it for you, but I will provide a shorter definition after I read it, okay? So the definition he gave is a computer program learned from experience E with respect to some class of task T and perform measures P if its performance at task in T as measured by P if its performance at task in T as measured by P improve experiment E. If you don't understand what does it mean, it's fine. Because I found another shorter definition of machine learning, and I really like it. It said a machine learning is a computer program that automatically improves its performance through discovering the regulatories of data with its algorithm. If you really want to know more about it, I really suggest you to go on to FDA and look at several documents they publish about machine learning and AI, especially about machine learning algorithm. They talk about what sort of the algorithms can only be registered for once, and then they can be used forever, even though you add new data, and what sort of algorithm that need revealed from time by time once you edit the code or input new data into it. From the report, I think FDA is very open to machine learning approach in healthcare. But in here, we might not spend too much time to talk about the detail. We will just keep go on. But you can definitely look at it by yourself. Be aware that machine learning is very, very different from the traditional statistical model that we had. And the reason why we are promoting machine learning and telediagnosis is because machine learning is more favorable when it's dealing with complex and increased level of complex data structure in healthcare. In order to explain the main difference between the traditional statistical model and machine learning is we do have a lot of pre-assumption had been made before we use the model. For example, if I get a set of data from a diabetic community in Boston, we look at the data and then we look at its mean, we look at its variance, we look at its distributions, and then we assume, okay, this one look like normal distributions, or this one should be fit in a chi-square task because it's a category data or category variable. We make a lot of pre-assumption. For example, we assume those two patients, they are independent from each other. This patient's information, this patient's data is very different from another patient's. And in most of the cases, that independence is a main pre-assumption for lots of the statistical model. And then we put those data into an assumed model. Then we think, okay, this model should be okay. This model should be the right tool. We put it into that model, and then we get a summary. But in this case, you can tell that sometimes the summary might not be satisfied. If the summary is not satisfied, how can we use the model? Sometimes the data is too complex. We got too many data, which is raised to the concept of big data. We got too many bad data. We're not able to look at it individually. But in this case, machine learning is very good at dealing with a large amount of complex data. But the problem with machine learning is it has been heavily critical for its black box paradigms, as some of the results are not clinically interpretable in biological term. For example, based on the machine learning algorithm we input data into it, we run it, and then we receive a result. The result we might not be able to explain it, even though we wrote the data. And in this case, lots of the healthcare professional might not trust the machine. It's very common to happen. And that's why in one of the reasons that machine learning might not be well adopted in some of the area in healthcare. So let's see several examples that have been used that's related to machine learning based diagnosis service. I've listed out a few. You can see asthma, cardiovascular disease, right? Parkinson's disease, even you can see there's a study developed in Japan about fetal telediagnosis for cardiac disease. That one actually is a very good study. If you have time, you can definitely go in and look at it, because there are not too many studies have done related to machine learning based telediagnosis for fetal, like for pregnant women. I might not go over all of them, because I do realize in different study we might use different machine learning method. Even though they are focusing on the same topic. But if you are interested in it, send me a message, and I can send you those articles or those journal that have been written. Before we finish, I would like to mention several interesting facts I find throughout this research. And those golden rules can be used and applied when you try to develop your own machine learning model for telediagnosis. I'm read it out for you. So the first one is a model with richer explanations preferred than the one doesn't. So be careful that the person who approve your model or approve your tools it's definitely those people with clinical backgrounds. People with clinical backgrounds do not necessarily to have a very strong IT background or computer visionary background. Be aware of that. So we do need to explain yourself. We do need to explain the model. As mentioned before, we got this black box issue. We can't explain a lot of things that's happening in between from the point we input the data into it and from to the point where we export an answer. And committee machine approaches prefer than a standalone algorithm. A group of algorithms seems to be more trustable than a single one. So, as mentioned, if you have applying several machine learning algorithms in one model, it can be more beneficial than a single one. And the machine learning algorithm should be able to integrate into the existing workforce. The same for all the health tech product or service. You should definitely be integrating the existing workforce or healthcare setting. Otherwise, no one will use it. Or even it will increase human error. It will create mistake, and some of the patients might lose their life because of this mistake. And most of the cases that the healthcare professional, they're using your algorithm or your product do not mean to do it, but it's just your product is new, your product is not fit in the clinical workflow. So be aware of that and do enough market research about the user, about the environment, about even the patient. Machine learning-based algorithm is viewed as an external source of information for healthcare providers. from the report I read from FDA, and also several reports published by the federal government, they do not recognize only human practitioners can send out prescriptions. Machine can't, and that does make sense, because when you see one of the reasons why I think, and lots of the healthcare professionals in the field think AI cannot replace humans care providers, is because healthcare is a very, very complex thing. When a patient sit down in a GP's office, they don't just come to look for an answer. They come for an experience. Of course, they want to improve their care, but in many of the cases, that medicine is not the only solution. Medicine is not the only key to deal with the situation that we are having now. A person's might feel pain, a lot of pain in their stomach, probably because they're stressed, probably because they work overtime, because they don't have enough diet. It's a very complex thing. It's more like humanity, and that's why we can't really only rely on machine learning algorithm. Because as I explained, AI, artificial intelligence, do not have emotions. It is not actual biological intelligence. It's more like mathematic model that we build up and then we shaped based on the data we input. And this explain the fifth one, which is human decision is always outweighed automatic detections in both legal and clinical aspect, even if some automated diagnosis system outperform the human decisions. And I did explain that already. And I'm also supporting with these opinions. The significant inflow of clinical data can be a positive signal for the development of automatic detection system. Yes, we're having a huge inflow of data nowadays. From our daily life to electronic health record we developed based on the existing infrastructure we implement in the hospital setting. And the larger amount of data, the more diverse the data, the better, the higher possibility for us to develop a better machine learning system that's able to deal with deal in a very complex environment. But bear in mind that a large amount of data input for a model do not mean that the model will perform extremely well and give the right answer all the time. If we give an example, I have written an article about using AI for epidemiologists and to deal with disease outbreak. Like Google have once developed an algorithm to detect flu. Well, in the flu season, that people are more likely to search for the symptom. People are more likely to search for the solutions, like what they should eat, what they should be more careful at, or should they find a doctor or not. It's more like Google doctors in some way. But anyway, they developed this algorithm when people search about flu, and when this number increased dramatically, they believe this is the flu season, and it functioned pretty well until they did not detect SARS. The SARS is actually disease happening approximately like 17 years ago. Yeah, in 2003, which killed 5% of the world populations, and the Google algorithm did not detect that. Because in the never face a disease outbreak like that, they don't know in a disease outbreak, even though you're not sick, you might still go on and search for the symptom because you are worried. And it actually, then their algorithm actually mess up because they don't know what to do. Anyway, we do spend approximately 15 minutes to talk about telehealth and telediagnosis and the machine learning in telediagnosis. if you are interested in supporting us, please go online, go to LinkedIn, find my profile, Christiane Zhao. I know my name is hard to spell, but please try to look at it and find my name, Christiane Zhao, and follow me. And I usually publish health tech related article in a monthly basis if I can, if I'm not busy, not too busy. If you're interested in look at other health tech video, or if you're interested in look at what the healthcare technology associations have done, please go to vimeo.com/caretech.com. But caretechdia, you can see from the PowerPoint, right? Go on and search for that. You can also visit my blog. I usually post the same article in LinkedIn and in my blog at the same time, but in the blog is easier for you to look at my old article and get to know me, right? My blog's URL is christianezhaoblog.wordpress.com. Very easy. Thank you very much. If you have any feedback, please come back to me. Send me an email, flip me a message in LinkedIn, or whatsoever. Or if you found me at university, feel free to say hi to me. Thank you very much. I'll see you next time.